Elias was a man who spoke the language of engines better than he spoke to people. For 50 years, he had run a small, grime-encrusted machine shop on the edge of the industrial district, a place where dying heavy machinery went to be resurrected or stripped for parts. His reputation was built on his uncanny ability to listen to a diesel knock and diagnose the problem within seconds, but the industry was changing. Modern electronics were replacing mechanical intuition, and his business was slowly suffocating. It was this desperation that led him to the naval auction yards on a rainy Tuesday morning. He wasn't looking for standard salvage. He was hunting for a specific lot that others had ignored. Lot 404 was listed simply as decommissioned marine propulsion unit, non-functional. It was a gargantuan 5,000 horsepower diesel engine, stripped from a mid-century ice-breaking tugboat that had served in the Arctic Circle. To the other scrappers, it was a 60-ton paperweight, too heavy to move and too rusted to be profitable. But Elias knew the manufacturer. He knew that this specific series of engines, built during a brief window in the early 1950s, utilized massive, over-engineered generator housings filled with incredibly thick, pure copper windings. He did the math in his head. The copper weight alone would save his shop for another 2 years. He placed the bid, wiping out his savings, and won the lot for the price of scrap iron. Moving the beast to his shop took 3 days and a specialized heavy-haul lowboy truck that strained under the immense weight. When they finally skidded the colossal engine onto the reinforced concrete floor of his workshop, it looked like a dark, oil-stained mountain of cast iron. It smelled of brine, ancient diesel, and the deep, metallic scent of cold steel. Elias's grandson, Caleb, who helped out in the shop on weekends, looked at the acquisition with skepticism. He saw a rusty money pit that had cost them everything, a relic that belonged in a smelter, not their workspace. But Elias saw potential. He ran his hand over the cold flank of the cylinder block, feeling the density of the metal. He explained to Caleb that the treasure wasn't the engine itself, but the generator head attached to the rear. That was where the copper lay hidden, wrapped in layers of insulation, waiting to be harvested. Hey everyone, before we crack this massive engine open, we have a huge request. We are incredibly close to hitting 10,000 subscribers, and it would mean the world to us if you could smash that subscribe button right now to help us cross the finish line. If you're enjoying these deep dive salvage stories, consider using the Super Thanks feature to support the channel directly. It helps us buy more crazy scrap like this. Also, drop a comment down below. Where in the world are you watching from? We love seeing our global salvage family. Now, let's get the wrenches and see what's inside this beast. The dismantling process began with the outer cowling of the generator section. The bolts were seized tight, rusted into single units of metal after decades of exposure to salt spray. Elias and Caleb had to use oxyacetylene torches to heat the nuts until they glowed cherry red, expanding the metal just enough to break the bond. It was grueling, sweaty work. The shop filled with the sharp smell of burning rust and ozone. One by one, the massive bolts shrieked and gave way. As they worked, Elias noticed something odd. The generator housing, which should have been standard cast steel, felt different under the torch. It didn't discolor in the way he expected. It held the heat longer, suggesting a unique alloy composition. Furthermore, the casing was sealed with a level of precision he hadn't seen on tugboats. There were gaskets made of a material that hadn't degraded despite 50 years of neglect, a rubbery compound that was still pliable. After 6 hours of continuous labor, they were ready to remove the main access plate, a heavy circular slab of metal 3 feet across. Elias attached a chain hoist to the eyelet welded onto the plate. Caleb operated the hoist, the chains rattling as they took up the slack. With a loud crack that echoed through the shop, the seal broke. Elias used a pry bar to guide the heavy plate as it swung free, revealing the internal cavern of the generator for the first time in half a century. They expected the dull, dusty darkness of a standard armature. Instead, they were met with a confusing sight. The interior was hermetically clean, free of the carbon dust and grime that usually coats old electric motors. Elias shone his high-powered inspection light into the cavity, aiming for the stator coils where the copper should be. He blinked, adjusting his glasses. The beam of light hit the massive coils winding around the core, but there was no signature orange glow of copper. The light reflected back with a brilliant, white-silver intensity. The coils were pristine, wound with a precision that looked almost machine-surgical, and they were made of a silvery metal that looked too bright to be aluminum and too lustrous to be steel. Caleb leaned in, confused. He asked if it was tinned copper, a common technique for marine environments. Elias reached in with a pocket knife and scratched the surface of one of the thick wires. It wasn't a coating. The metal was silver all the way through. It was heavy, dense, and cold. Elias felt a knot form in his stomach. If this was aluminum, the scrap value was worthless, and he had just bankrupted his family. But the weight was wrong. Aluminum was light. This material had a gravitational pull to it. He realized they weren't looking at a standard generator. They were looking at something experimental, something that wasn't supposed to be on a commercial tugboat. The atmosphere in the workshop shifted from one of weary labor to a suffocating tension. Elias stood frozen, the small pocket knife still resting against the gouge in the wire. The exposed metal beneath the insulation didn't oxidize or dull. It gleamed with a milky, lunar whiteness that was unmistakably distinct from the harsh shine of chrome or steel. Caleb, sensing the gravity of his grandfather's silence, moved closer, the heavy work boots crunching softly on the metal shavings scattering the floor. He handed Elias a heavy-duty file from the workbench. Elias took it, his hands trembling slightly, not from age, but from the adrenaline of the unknown. He ran the file across the thick cable. The metal was soft, yielding easily to the tool, curling away in heavy, non-magnetic shavings. It lacked the springy resistance of aluminum. It felt dead, dense, and incredibly substantial. Elias reached for a magnet on his tool tray, a strong rare earth magnet he used to fish bolts out of oil pans. He hovered it over the exposed coil. There was zero reaction. The metal ignored the magnetic field entirely. Elias knew there was only one way to be certain, a test he hadn't performed in decades. He moved to a locked cabinet in the back of the office, retrieving a small, dust-covered wooden box containing a jeweler's acid testing kit, a relic from his father's time. He returned to the engine, the glass vial of nitric acid clutched in his grease-stained fingers. Caleb held the flashlight steady, the beam cutting through the suspended dust motes. Elias carefully placed a single drop of the acid onto the fresh file cut. If it was aluminum, nothing significant would happen. If it was some cheap alloy, it would turn green. The drop hit the metal and immediately frothed, turning a rich, creamy red color. Elias let out a breath he didn't know he was holding. It was silver. High purity. Solid silver. The implication was staggering. During the frantic production shortages of the wars or specific Cold War projects, copper was sometimes diverted for shell casings, and the government utilized strategic treasury reserves of silver for industrial conductors, most notably in the Manhattan Project. But to find such a configuration in a tugboat engine was unheard of. Elias did a quick mental calculation. The stator coils were massive, winding around the core in thick, braided bundles. There were easily over 3,000 pounds of wiring inside the generator head. If this was indeed solid silver, the scrap value wasn't just enough to save the shop. It was worth exponentially more than the entire building and everything in it. They were looking at a multi-million-dollar block of precious metal disguised as a rusted maritime relic. However, the discovery raised more questions than it answered. Why was a tugboat carrying a generator built with strategic reserve bullion? They returned to the dismantling process with a newfound reverence and caution. They were no longer tearing apart scrap, they were excavating a bank vault. They carefully unbolted the stator housing, using the overhead crane to inch the heavy steel casing backward. As the internal components were fully exposed, the sheer volume of the silver wiring became apparent. It was a work of art, a masterclass in electrical winding that far exceeded commercial standards. As they cleared the solidified grease from the base of the generator housing to access the lower mounting bolts, Caleb's scraper hit something that didn't sound like cast iron. It was a flat, rectangular plate riveted to the side of the oil sump, completely obscured by decades of bilge sludge. After 5 minutes of scrubbing with solvent and a wire brush, the brass plate revealed its stamped text. It wasn't the standard engine manufacturer's tag. It bore the insignia of a naval research laboratory and a classification code, Project Arclight, Mobile Auxiliary Power. The specifications listed were not for propulsion, but for high-frequency radar output. This engine hadn't just been pushing a boat through ice. It had been a mobile power station designed to generate incredibly clean, high-amperage electricity for sensitive military equipment in the Arctic, likely early warning radar systems that required the superior conductivity of silver to function efficiently in extreme conditions. The mystery deepened as they moved to the rear of the crankshaft. To separate the generator from the engine block, they had to decouple the main drive shaft. It was a massive steel cylinder, usually solid. But when they removed the coupling bolts, they noticed a seam running effectively around the circumference of the shaft end, sealed with a flush-mounted lead plug. It looked like a maintenance cap, but placed in a location that would be mechanically impossible to access while the engine was running. It was a hiding spot designed by an engineer. Elias drilled a small pilot hole into the lead plug. The drill bit punched through easily, dropping into a void. It wasn't solid steel. The crankshaft was hollow. Elias hooked a slide hammer into the pilot hole and, with a few sharp strikes, pulled the lead cap free. Inside the hollowed-out center of the driveshaft lay a cylindrical, watertight tube made of brass, wrapped in oil-soaked canvas. It had been spinning inside the engine at hundreds of revolutions per minute for years, perfectly balanced and hidden. Elias reached in with long nose pliers and extracted the tube. The brass was tarnished but uncorroded. He unscrewed the end cap. Inside rolled out a set of tightly wound, blue-tinted blueprints and a small, leather-bound logbook. The papers were dry and crisp. They unrolled the blueprints on the dirty workbench, weighing down the corners with heavy wrenches. These weren't just engine schematics. They were installation diagrams for a secondary containment unit located not in the generator, but deeper, inside the engine block's massive oil pan reservoir. The blueprints depicted a false bottom in the sump, shielding a compartment labeled catalyst storage. The silver coils were just the conductor. The engine was built to power something else, and according to these documents, a critical component of that system was still sealed inside the belly of the beast. The revelation of the hollow crankshaft and the concealed blueprints shifted the entire operation from a salvage job to a tactical excavation. The blueprints detailed a Level 4 containment, hidden within the engine's massive oil sump. On a standard 5,000 horsepower diesel engine, the sump is simply a giant steel tub bolted to the bottom of the block, designed to hold hundreds of gallons of lubricating oil. It is usually the filthiest, most neglected part of the machine, filled with sludge, metal shavings, and condensed water. Elias knew that if the government wanted to hide something permanently, the bottom of a sludge-filled crankcase was the perfect place. No one ever looked there unless the engine had suffered a catastrophic failure. The first challenge was access. The engine sat on heavy timber cribbing, leaving only a few inches of clearance beneath the oil pan. They couldn't unbolt it from the bottom. They had to go in from the top, through the crankcase doors. This meant Caleb, being the younger and more agile of the two, had to suit up in a full-body rubber chemical suit and crawl inside the engine block itself. They spent the next 4 hours draining the residual oil. It didn't flow like liquid. It oozed out like black molasses, thick with decades of oxidation. The smell was overpowering, a toxic mix of sulfur and rot that made the eyes water. Once the bulk of the fluid was gone, they pumped in 50 gallons of diesel solvent to cut the remaining sludge, flushing the system until the metal began to show through the grime. Caleb climbed into the engine through one of the side access panels, squeezing his body between the massive connecting rods and the cast iron walls. It was a claustrophobic nightmare. He was surrounded by the cold, crushing weight of the machinery, his headlamp cutting a cone of light through the lingering oil mist. According to the blueprints, the false bottom wasn't welded across the entire pan. It was a subcompartment located directly under cylinders 3 and 4. Caleb wiped away the remaining film of oil from the floor of the pan. To the naked eye, it looked like standard baffling, steel plates designed to stop the oil from sloshing around in rough seas. But when he ran his gloved hand along the seam where the baffle met the floor, he felt a discrepancy. The welds were too smooth, too perfect. They were machine-done, unlike the rough hand welds on the rest of the sump. He signaled to Elias, who passed him a pneumatic chisel and a heavy hammer. There was no room for a cutting torch inside the oil-soaked crankcase. The fumes would have turned the engine into a bomb. This had to be done with brute force and cold steel. Caleb positioned the chisel on the weld seam and pulled the trigger. The deafening rattle of the air hammer amplified inside the cast-iron echo chamber, vibrating through Caleb's bones. Inch by agonizing inch, he sheared the steel weld. It took 2 hours of back-breaking labor in the cramped dark to cut 3 sides of the access plate. With a final heave of the pry bar, the steel flap groaned and bent upward, revealing the dark void beneath. Caleb shone his light into the hole. It wasn't just an empty space. Nested snugly in a bed of dense, rubberized packing foam were 4 heavy, olive-drab metal cases, each about the size of a car battery. They were latched and sealed with lead security tags. He carefully attached a rope to the handle of the first case, and Elias hauled it up through the engine block, hand over hand, straining against the weight. The case was disproportionately heavy for its size, suggesting dense contents. They repeated the process until all 4 cases sat on the workbench, dripping with the solvent and oil from the extraction. Elias wiped the first case down with a rag. The stencil on the lid was faded but legible: Catalyst, RHPT series, do not open in direct sunlight. He recognized the chemical symbols immediately: rhodium and platinum. The logbook they had found in the crankshaft provided the context. The Project Arclight generator required a specific catalytic converter system to scrub the exhaust of the massive engine to nearly zero thermal signature, allowing the tugboat to operate undetected by thermal imaging while powering the radar array. The catalyst plates were made of solid platinum alloyed with rhodium, materials chosen for their extreme heat resistance and chemical stability. When the project was scrapped, the engineers, likely fearing the valuable materials would be looted by corrupt shipyard officials, had sealed the catalyst cells inside the engine's oil reserve, intending to recover them later. They never returned. Elias used bolt cutters to snap the lead security seal on the first case. He flipped the heavy latches and lifted the lid. Inside, resting in custom-molded velvet slots, were 10 rectangular plates. They weren't shiny like the silver wire. They were a dull, matte gray, heavy and unpretentious. But Elias knew exactly what he was holding. Rhodium was one of the rarest and most valuable precious metals on Earth, often trading at prices 10 times higher than gold. Platinum was a close second. These weren't microscopic coatings on a ceramic honeycomb like in a modern car. These were solid, thick plates of the alloy, designed for industrial-scale naval warfare. He picked one up. It weighed nearly 5 pounds. There were 10 plates in the box, and 4 boxes total. 40 plates of solid platinum-rhodium alloy. The sheer density of wealth sitting on the greasy workbench was hard to comprehend. The silver wire in the generator head was a fortune, but this was generational wealth. This was the kind of discovery that governments killed to keep quiet in the 1950s. Elias looked at the logbook again. The final entry was hasty, written in a different pen. Unit sealed. Assets secure. Weather turning. We leave at dawn. The crew had abandoned the engine to the elements, hiding the treasure so well that it took 70 years and a desperate old mechanic to find it. But the blueprints had one final detail, a small footnote in red ink at the bottom of the page that Elias had missed in the initial excitement. It pointed to the massive flywheel at the back of the engine, the multi-ton steel wheel that smoothed out the engine's pulses. The note read, "Primary calibration weights, uranium depleted." Elias froze. The weights used to balance the flywheel weren't lead. They were depleted uranium, used by the military for its extreme density to balance high-speed machinery in compact spaces. While not highly radioactive, it was legally hazardous and strictly controlled. They had uncovered a fortune in silver and platinum, but they were also standing next to a massive chunk of regulated nuclear byproduct. The engine wasn't just a treasure chest, it was a radiologic hazard. The silence in the workshop was broken only by the sporadic, dry clicking of a Geiger counter Elias had retrieved from his office safe, a relic from the days when he worked on nuclear-powered vessels in the naval yards. He held the probe inches from the massive flywheel at the rear of the engine. The needle danced, not into the red zone of acute danger, but high enough to confirm the logbook's warning. The clicks accelerated into a static hiss near the rim weights. These were indeed depleted uranium, Du, a material twice as dense as lead, used by the military to balance high-torque machinery within compact spaces. While not highly radioactive in a way that would cause immediate sickness, the heavy metal was chemically toxic and posed a severe legal and health risk if handled improperly. If they inhaled dust from the weights, it would be catastrophic. The engine had transformed from a treasure chest into a hazardous waste site. They immediately stopped all percussive work. There could be no grinding, no cutting, and no hammering near the flywheel that might create dust. They donned full-face respirators and heavy rubberized hazmat gloves. The removal of the Du weights became a surgical operation. Elias set up a negative pressure tent around the rear of the engine using plastic sheeting and a shop vac fitted with a HEPA filter to capture any potential particulate. Working with painstaking slowness, they used hand wrenches to back out the high-tensile bolts securing the curved uranium weights to the steel flywheel. Each weight, though small in visual dimension, was shockingly heavy, requiring both men to lift it and place it gently into a lead-lined battery box Elias had improvised for storage. It took 6 hours of nerve-wracking focus to strip the flywheel bare, removing the radioactive hazard and neutralizing the immediate threat. With the hazardous phase complete, the workshop shifted into a mode of industrial harvest. They now had to process the assets they had uncovered. The generator head, stripped of its casing, looked like a giant spool of silver thread. The process of unwinding the stator was grueling. The silver wire, unlike copper, did not work harden as quickly, but it was wrapped under immense tension and coated in a vintage, resin-impregnated insulation that was as hard as rock. They couldn't burn it off without melting the silver, so they had to mechanically strip it. Elias built a custom jig on the workbench, feeding the thick silver cable through a set of adjustable blades that sliced the insulation lengthwise. As Caleb pulled the wire through, the coating fell away, revealing the gleaming, pure metal underneath. They worked in shifts for 3 days straight, sleeping on cots in the office, fueled by coffee and adrenaline. The pile of stripped silver wire grew into a shimmering mound in the corner of the shop, a chaotic tangle of wealth that looked almost alien against the grime of the concrete floor. Once the wire was processed, they turned their attention to the platinum-rhodium plates from the oil sump. These required a different approach. Coated in 50 years of polymerized oil sludge, they needed to be chemically cleaned to assess their true condition. Elias prepared a bath of ultrasonic solvent. One by one, the plates were submerged. The ultrasonic waves cavitated the fluid, blasting away the grime on a microscopic level. When the first plate emerged, rinsed and dried, it was a dull, gunmetal gray, unpretentious and heavy. Elias placed it on his precision digital scale. It weighed exactly 2.2 kilograms. He did the math on a notepad. With 40 plates in total, they were holding 88 kilograms of one of the rarest alloy groups on the planet. The market value fluctuated, but the raw material alone was worth vastly more than the silver. The combined value of the silver wire and the catalyst plates was astronomical, a number that didn't just mean retirement, it meant a dynasty. However, a new problem arose as the adrenaline faded. They possessed millions of dollars in strategic metals, but they had no way to sell them. They couldn't simply walk into a local scrapyard with 3 tons of pure silver wire and military-grade platinum plates. It would trigger an immediate police investigation. The materials were too pure, too specific, and clearly of government origin. To sell this, they needed legitimacy. They needed to prove that they owned the salvage rights to the materials, not just the steel of the engine. Elias spent a night poring over the auction paperwork. The manifest was vague, listing 1 marine propulsion unit and accessories. It was a legal gray area. If they melted the silver, they destroyed its provenance, but they could sell it easily. The platinum, however, was stamped with serial numbers. Elias decided to investigate the origin of the engine to establish a chain of custody. He returned to the stripped flywheel. With the uranium weights removed, the casting surface of the wheel was visible for the first time. He used a wire brush to clean the metal where the weights had sat. Etched into the steel, previously hidden by the radioactive ballast, was a second set of identification marks. It wasn't just a serial number. It was a vessel designation, USS Borealis EXP, refit 1952. Elias froze. He knew that name. The USS Borealis was a legend in maritime circles, a naval support vessel that had officially vanished during a severe storm in the Bering Sea in the early 50s. The official story was a total loss with all hands, but rumors had always persisted that it was involved in covert listening operations against the Soviets. The engine sitting in their shop was the heart of a ghost ship. The fact that the engine was here, in a scrapyard auction, meant the ship hadn't sunk. It had been secretly stripped, decommissioned under a fake name, and its most valuable, classified components buried in the surplus system to hide the evidence of whatever mission it had been on. This discovery changed everything. They weren't just scrap dealers with a lucky find. They were now holding the physical evidence of a 60-year-old naval cover-up. The platinum plates weren't just valuable metal. They were proof of a black-budget technology that never officially existed. Elias realized that selling the metal on the black market would be a mistake. It would be pennies on the dollar and risky. The true value lay in the history. The U.S. Navy, or at least the Naval Heritage Command, would pay a fortune to recover these assets quietly to preserve the history, or to bury it again. But if they approached the wrong person, the government would simply seize it all under the Espionage Act. They needed a broker. Elias reached for the phone and dialed a number he hadn't used in 20 years, a lawyer in D.C. who specialized in maritime salvage and difficult government acquisitions. The game had moved from the workshop to the courtroom. They had to negotiate a surrender of the assets, not a sale. The terms of that surrender would determine if they became millionaires or federal prisoners. The arrival of Silas Vance, a lawyer whose suits cost more than Elias's entire yearly overhead, marked the turning point. Vance didn't come alone. 2 days after the phone call, a convoy of 3 black government SUVs pulled into the gravel lot of the machine shop, looking starkly out of place against the backdrop of rusting tractors and piled scrap metal. Elias and Caleb stood at the bay door, arms crossed, the auction receipt for Lot 404 pinned to a clipboard in Elias's hand like a shield. Men in dark suits and naval uniforms stepped out. They weren't police. They were from the Naval History and Heritage Command and the Office of Naval Intelligence. The tension was thick enough to cut with a torch. They weren't there to raid the place. Vance had ensured that, but they were there to verify a claim that sounded impossible on paper. The inspection was conducted in near silence. The naval experts moved through the shop with clinical precision. They examined the silver windings, the hollow crankshaft, and finally, the crates of platinum-rhodium catalyst plates. When the lead historian, a stern man with white hair, saw the Project Arclight logbook and the specific serial numbers on the catalyst cases, his professional demeanor cracked. He ran a gloved hand over the stamped metal, whispering, "It wasn't lost at sea." The USS Borealis hadn't sunk in the Bering Sea as the public record stated. It had been secretly towed back, stripped of its classified identity, and scrapped piece by piece to hide the technology. A clerical error in 1952 had mislabeled the main engine as standard surplus, allowing the heart of the secret project to drift into the civilian market, where it sat unnoticed until a stubborn mechanic decided to tear it apart. The negotiation took place in the cramped, grease-smelling office. Vance did the talking. The government wanted the assets back, specifically the catalyst plates and the blueprints, which were still technically classified technology despite their age. The depleted uranium was a hazmat issue they were happy to remove. However, Vance argued effectively that Elias had purchased the engine legally at a public federal auction. He held the title. The government had sold their own secrets by mistake. They couldn't seize it without a PR nightmare and a lengthy court battle they would likely lose on property rights grounds. The only solution was a buyback. They had to purchase the scrap at its current material value, plus a finder's fee for the recovery of significant historical assets. The valuation was staggering. The silver wire alone, over 3,000 pounds of high-purity conductor, was worth a small fortune. But the real leverage was the rhodium. In the decades since the engine was built, rhodium had exploded in value, becoming one of the most expensive metals on Earth, far outstripping gold. The 40 solid plates in the oil sump were not just industrial parts. They were a condensed treasury. The government actuaries crunched the numbers, looking for a way to minimize the payout, but the market price was undeniable. The final settlement offer was presented: $4.8 million USD for the metals, the return of the classified documents, and the safe removal of the uranium weights. Elias signed the papers with a hand that was steady for the first time in weeks. The SUVs were loaded with the crates of plates, the spools of silver wire, and the lead-lined box of uranium weights. The agents left as quickly as they had arrived, leaving behind an empty engine block and a life-changing check. The shop was suddenly quiet again, save for the hum of the old refrigerator in the corner. Caleb looked at his grandfather, expecting a celebration, a shout, something. But Elias just walked over to the massive, stripped cast-iron carcass of the engine. They didn't sell the block. The massive 5,000-horsepower iron skeleton remained in the center of the shop. With a portion of the money, Elias renovated the entire facility. They installed new CNC machines, upgraded the ventilation, and hired a team of younger mechanics to handle the modern workload. But the centerpiece remained. They sandblasted the engine block, painting it a deep, glossy industrial green, and mounted it on a permanent concrete plinth in the lobby of the new Elias and Son Marine Restoration Headquarters. They cut away the side of the crankcase and installed thick glass, illuminating the hollow interior where the fortune had been hidden. It became a legend in the local industry, a monument to the philosophy that Elias had lived by. Nothing is ever just junk if you know how to look at it. The money ensured that Caleb would never have to scrape for a living, but the lesson of the engine was more valuable. The useless rusted tugboat engine that everyone else had ignored had contained the seeds of their future, hidden under layers of grease and bureaucracy. Elias retired from the daily grind, but he could still be found in the shop most mornings, drinking his coffee and watching the apprentices work, his hand occasionally resting on the cold iron flank of the machine that had tested him, frightened him, and ultimately saved him. The USS Borealis finally had a resting place, and the old mechanic had his victory.